right, this is all about characteristics. That word characteristics, if you were talking about a person and you were talking about their characteristics, you might describe physical appearance or personality traits, what they're wearing, what they're like to be around, what sports they play, what do they like, what do they not like. Characteristics of functions, you can look at it as describing different parts of the graph. Where's its highest point? Where's its lowest point? When's it going up or increasing? When's it going down or increasing? When does it go from increasing to decreasing? When is it hitting the x-axis? We call those zeros. But these are the things we need to know. We need to know increasing, decreasing. Now these are all in that foldable that you already have. Remember, increasing means the graph is doing what? Going up. Going up. Like that. Decreasing means it's going down. Turning point. This is probably a new one. A turning point is a point where the graph goes from increasing to decreasing. So if you have a graph that is going up and then it switches to going down, that point where it switches from increasing to decreasing is called a turning point. Now the opposite is true. If it starts by going down and then turns to going up, decreasing to increasing, the point where it switches between the two is called the turning point. You know, the graph is turning directions. It's going from one slope to another slope. Okay, and then we got max and min. Maximum is your highest point. Minimum is your lowest point. Okay, highest point, lowest point. These pictures are super similar. If we had a graph that looks something like this, here's your maximum. That's your highest point. If we had a graph that looks something like this, your minimum is your lowest point on the graph. Last but not least is a zero. This is when your function or graph is equal to 0. So every function is on the coordinate plane with an x-axis and a y-axis. Depending on what your graph looks like, it can have no zeros, it could have 1 zeros, it could have 20 zeros. A 0 is whenever your graph crosses that x-axis. So let's draw a picture. And this is just a squiggle I'm making up right now on the spot. How many zeros does that squiggle have? 4. 1, 2, 3, 4. A 0 is when our graph crosses the x-axis. All 4 of these points have a height or a y value of 0. That's why we call them 0. At that point, none of the points are above or below. It's at 0. Okay, these are the definitions we're going to need to know and that you'll be asked when looking at functions. Today you're just describing a function, just like you would describe a person in real life. Okay, let's look at our first example. So this function is a graph that represents a dam's control over a reservoir water system. So if you didn't know, a dam holds back water, but it also controls water height. They have like channels where, if you know like the Panama Canal, big boats will go into this channel, they'll fill it up with water to raise the boat up so it can keep going. So this is what we're dealing with. We're water levels raising and lowering. So if we kind of read through this, you can see how this graph is made. At the start, the water level is currently steady and above normal. So if you look at our function, see how it's above 0 and it's steady. meaning it's not going up, it's not going down, it's constant. All of a sudden then, to prepare for coming rain, the engineers lower the water level at a constant rate. So now what's the water doing? It's going down until it's below that normal level, which is our x-axis. So it's gone down into the negative. So it starts to rise rapidly with the rain. So here we go. We start rising rapidly. And then it says we're gradually leveling off. So we can see how that story can be represented using a function, a graph. Now this function has lots and lots of our vocab, and we're going to just work on filling them out. I'm going to give you two of them because we didn't necessarily talk about them. This top left one, which points, it looks like at the start of the graph, but it's looking at this whole top half. This whole top half is called the positive. That whole top half of our coordinate plane, everything above the x-axis, those are all positive values. Okay, that's when the water is above normal, positive values. Everything under the x-axis we call the negative. The negative. Everything on the bottom is when the water level is below normal, below zero, the negative. Now the rest are ones we can fill out using those key words we have. So let's look at our first blank on the left. This is pointing at this line right here. What's a good characteristic, a good way to describe what this line is doing? What is that section of our function doing? Yeah, Michael.
It's decreasing.
It's decreasing. Whoa. It's decreasing. From a little after 4 until a little after 9, the water level is decreasing. That's a perfect characteristic. I don't know how else we would describe that portion of the graph. It is going down. Okay, let's work our way to the bottom right. The bottom right bubble is pointing at this point that's somewhere between, 8 and 10 o'clock. What's a good characteristic, like I might say Kravitz has brown hair. How would we describe that point? What is it? Which one of our characteristics fits? Minimum. Because this point is the smallest, lowest. It has the smallest y value, but this is our minimum. And today is it's mostly vocab. Can you look at a function? Can you look at a table and describe each part of the graph? Okay, let's keep going. Next box, right above. Points, kind of at the point, but also at the lines. What's happening during that portion of the graph? It's increasing. This function is increasing from when? About 9 o'clock, maybe a little after 9, until 18 o'clock, which is, 4 p.m. in military time. It is increasing. Okay. This point at the very top right is our maximum. The water level never gets above that point. That's the highest the water level gets. It's the maximum. And I left this one for last because the picture does a poor job, but it's actually pointing at two things. It's actually pointing right here and right here, but that bubble is poorly placed. What characteristic describes those 2 points? 0. That's when the water level isn't above, it's not below, it's right at normal. This is our 0. Okay, these are the things you're going to have to be able to look at a function or table or graph and recognize. Hey, when's it going up? When's it going down? When's it at the highest? When's it at the lowest? Okay, there's one word that isn't on here. There's one other word we could have put at minimum. What could we have also said for where we wrote minimum? Turning point, because what is the function doing there? It's going from decreasing to increasing. So turning point could have also been written in that bottom right. It's both. And your maximum and minimums will always be a turning point as well. Because what makes a max and what makes a minimum is the function changing from between the two. That's everything we need to know right there. Now we will do an example. Go, go, go. Good, take a picture. Beautiful. Alright, let's knock one out. We get to plot some points. Read a story. Big thing about Algebra 2 is interpreting words into math. Which is low-key the hardest part. Math here is not that hard. We got to interpret though. Sketch a graph of the following situation. So, before we do anything, let's take a look at our coordinate plane. What do we got? We got an x-axis. It goes from -6 to 30. We got a y-axis. There are no numbers. We'll deal with that as it goes. We're going to take these words, these many sentences, and we are going to turn it into a visual graph representation. The sun rises at 6 a.m. What should we do with that statement? The sun rises at 6 a.m. It's going to go up, for sure. Where is our graph going to start? Where do we need to put a point? Positive 6 or negative? I would say positive. At positive 6. And why are we going to put it right on the x-axis? Why isn't it above or below? Why would we put it right there? Because that's when the sun rises. What is this x? What could you think of this x-axis as being? The x-axis represents time. The y-axis, what's it going to represent? The height of the sun. And when the sun is just rising, when you look at it, it's like a point on the x-axis. It's like just barely coming above the ground. So this is our start. So the sun's going to rise at 6 a.m. That's when we first see it. It's going to reach its highest point above the horizon. It's going to reach its highest point above the horizon at 12 p.m. So we should go to 12. Do we know how high it goes? It doesn't say, but we do know that it's going to be above the horizon. So the only wrong answer would be to either put it on 12 or below it. So as long as you go above it, we're following the story. So I'm just going to go 2 boxes up. You can go 3, you can go 1, you can go 4. It doesn't matter as long as your sun is above the horizon at 12. And we keep going. The sun sets at 6 p.m. So what's going to start happening after 12? Going down. Uh-oh, 6 p.m. My numbers are still going up. 18 is 6 p.m. What? Yep. So at 6 p.m., which is 18, where are we plotting the point? Relative up and down? Below? On it. It's 0, right? The sun is considered to be setting, you know, when you go out and see it, that nice orange, red color, and it's like right level with the horizon. It's going to be right at the horizon, right at the ground. Okay, and we have one more little portion. It reaches its lowest point below the horizon at 12 a.m. And 12 a.m., the Carmen said, is at 24. Again, does it say how low? We don't know how low, so as long as you put your point below in the negative, you're good. So at 24, you're going to go down. I'm just going to go down too, because I like a nice symmetrical graph. And there's our sun. We can no longer see it, but we know it's still setting on the other side of the earth. And now what should I make sure I do? Connect them, yes, exactly. Our sun doesn't just like flash 4 times a day. You know, it rises and it falls. So there's our sun. Now we can definitely answer all of our questions. You can be fancy and draw a little sun even. See, there's my sun. Beautiful. Isn't it? When is the sun rising? In other words, increasing. 6 till 12. Whenever you are asked for an interval, when is it doing X, Y, Z? You need to give a start and a finish. In English, we would say from 6 a.m. to 12 p.m. Right? Agree? That is when it's rising. But in math, we want to use intervals. Okay? So we're going to use our brackets because we don't have any holes in the graph. It starts at 6 and it ends when? At 12. 6 to 12. And look, way less writing. 6 to 12. Okay, when is it setting or decreasing? Yep, 12 p.m. to 12 a.m. In the math world, we would say from when to when? 12 to, 12 to 24. When does the sun have a turning point? At 12 a.m. or p.m.? Isn't this p.m.? 12 p.m. At 12 p.m., we have a turning point because we were increasing and then we turned to going decreasing. When is the sun at its maximum height? Also 12 p.m. How about the lowest point? 12 a.m. Or at x equals 24. I guess we could also say max is at x equals 12, but that's actually the same. Last but not least, our zeros. When is our sun at the horizon? Yep, 6 a.m. and 6 p.m. In the math world, we would say at x equals 6 and x equals 18. Those are our characteristics. That's what we're focusing on. Can you look at a graph, can you look at a table, and can you describe what it looks like? And just like we describe things. Paper is thin, usually white, but can be many other colors. Sometimes it has ink on it. Sometimes it's a coloring page. Sometimes it's a crossword. Just describing what you're seeing. Don't overthink it. Last last example of the day. And it has to do with average rate of change. This is the last thing you need to know, and you know everything you need to know for the quiz on Wednesday. This is the formula for average rate of change. Now that I do not expect you to memorize this, but it is a good thing to know. And we're going to discuss what does this mean in plain old English. F of b minus f of a over b minus a. This helps us find the average rate of change between 2 points in our graph. We're finding the average of how much it increases or decreases. In order to, understand this a little easier, and some notes I would make on your paper, is this just is the same thing as saying the change in y. So the change in the y value, how much has it changed? How much has it gone up or how much has it gone down? Divided by the change in x. And you divide. How much did the y value change? And then you divide it by how much has the x value changed. And when you divide, it gives you the average change. It tells you about how much the graph has changed from a starting point to a finishing point. You might see a graph that's all wiggly, right? This is going to give you one number, and that number is going to tell you if it generally went up, or generally went down, or stayed the same. Have you ever seen those stock graphs that are like, you might look at one little part and it looks like it's going down. But in the big picture, if you take the average rate of change from the start of the day, when the stock market opens, to the end of the day, when it closes, even though there are parts where it went down, the average might be going up. And that's when you would want to sell your stocks, when it's going up, on an average. Okay, so let's do this. Okay. We got more water. The table models one day's predicted tide heights in relation to the mean lower low water level, or the MLLW. Okay. At the Weymouth Fore River Bridge, Massachusetts. So here's just a little picture to show you. Here is the water, and as you know, our oceans have tides, and during different times of the day, the water level will change significantly. Someday it may come all the way up to the houses, and later in the day it might be 200 yards back, and you can walk all the way out to it. Water comes in and out throughout the day. Here's a tide chart, which if you've ever been somewhere where there's a tide, or have lived there, this is something like in their everyday weather. It's what people like to know, like when's the tide in, when the tide's out, so they know what's a good time to swim, when is it dangerous to swim. You've probably seen movies where tide comes in and people get trapped. They do that in movies all the time, I feel like. So here is our time. And here is the height of our water. Okay, so again, we're going to create a graph, and we are going to do some average rate of change examples. Now, one thing that I want to show you that you will often have to do. Are graphing times very good? Like, do I really want to do 12 a.m., 2 a.m., and then it goes back to 12 p.m. Is that good for us? No. So whenever you see a table like this, it is good to take a second, take your pencil or whatever, and just start it off at 0. 12 a.m. is going to be our start. And then our graph is counting by every 2 hours. So 0 hours, 2 hours, 4, 6, 8, 10, 12, which you're like, Tokar, you're writing all the same numbers, but instead of going back to 2, because our x-axis doesn't go back to, back in time, it doesn't work like time, it keeps going up. So we'd be 14, 16, 18, 20, 22. There's almost one full day, 22 hours. it's just a lot easier to interpret than trying to like change our times into math, or math back into times. Instead of counting the time a day, we count how many hours. So let's plot some points. And now, I will warn you, this graph, the scale is just awful, so we're going to do our best. It's hard to tell exactly where the points are, just do your best. So, grab your pencil. At 0, what is the height of the water? 1.19. Can we perfectly plot this? Not really, but we're going to do our best. This graph counts by 2, so 1.19 is going to be, somewhere up in that area. Do your best. Okay? If you're someone who's terrible at organization, put a check mark as you go so you know what you've done and what you haven't done. Next one, 2 a.m. 1.33. That's going to be just a little bit above it, right? So do your best. But, at 2, I said 1. At 2, here's our 2. We're going to go, just make sure it's a little bit above it. And this is a sketch of a graph. It's not going to be a perfect representation, but it'll be good enough for us. Done with that bad boy. At 4, or 4 a.m., we're at 5.05. So at 4, we have 2, 4, halfway up. There's 5. At 6, we're at 8.57. Here's 6. 2, 4, 6, 8, and a little bit more. There-ish. At 8, we got 8.66, so 2, 4, 6, 8. A little bit higher than the last one. Again, doing our best. I lose track of stuff easily, so I'm going to put a check mark. At 10, we're back down to 5.37. 2, 4, up halfway. There's about where I'm going to be. At 12, at noon, 1.92. Almost at 2, but not quite. At 2 p.m., we're at 14. We're at 1.27. At 16, 5.0924, halfway up. At 18, or 6 p.m., 9.132468, halfway up. There's 9 about. At 20 or 8, we're at what? 10.25, 2, 4, 6, 8, 10, and a little bit above. And finally, at 10 p.m. or 22 for us on our x-axis, we're at 7.03. 2, 4, 6, halfway. It's about 7. And we should probably connect our dots. From right to left. So now we kind of have a nice visual representation of our water going. What's our water do? It goes up, stays for a little bit, goes down, stays for a little bit, and then back up and down. Okay? Which is what a tide does. It comes in and out a couple times. It looks like about 2 times in a day, huh? Now we are going to use this in our table to help us find the average rate of change. Again, what that means is we're going to see about what's the average amount of water that's either coming in or going out. So B asks us, what are the average rate of changes between the first flow tide and the first high tide. And then for the second low tide and high tide. So where is the first low tide? 12 a.m. Yeah, 0. Yeah, I would say 12 a.m. is the start of the second. So from 0 till when's the high tide? 8. 0 to 8. We go low to our highest point. That's our first low to high tide. So we're going to try to figure out, okay, so how much is the water rising on average? We're figuring out each hour, how much does the water start to go up? So we're going to do our change in our y values divided by the change in our x values. And we said we're going from 0 to 8. So from 0 to 8. Now we only care about the starting and the ending point. That's all we need to figure out our average rate of change. So we first need to figure out what is our change in y. To measure change, we subtract. So how much has the water changed from 0 to 8? In other words, we just subtract 8.66 minus 1.19. $8.66 minus, what did I say? 1.19. What is that? 7.45. 47. Okay. Divided by the change in x. So now we're figuring out how many hours went by. So 8 minus 0. How many hours happened from 0 to 8? 8 hours. So 8 minus 0 is 8. And now we can figure out how much water, how's the water changing per hour. So let's divide. I don't remember. I need you. 7.47 divided by 8. What do we got?
0.9375.
Yeah, we can just round to 0.94 or 934. 934. That is the average rate of change. And now this is how much is changing. If we look at our y-axis, this is feet per hour. So about how much is the water rising by per hour? Almost 1 foot. So every hour from 0 to 8, the water is rising about 1 foot at a time. I mean, a little less, it's 0.934, but that's almost 1 foot. Okay, and now it wants us to do it for the second low tide. So you guys are going to do this. Where is our second low tide? It starts at 14, and it goes till 20. 14 to 20. So you are going to do from 14 to 20. Remember, you are only looking at that first and last point. We don't care about the middle point. So find your change in y, divide it by your change in x. Your change in y divided by your change in x. Yep. Okay. I mean, if you wrote 1.497, that's fine. I just rounded to 1.50 feet per hour. Okay. So again, our height changed. It went from 1.27 feet to 10.25 feet. So that was a change in about 8.98. And it was over from 14 hours to 20 hours, which is a total of 6 hours. When we divide our change in height and change in time, we get about 1.5 feet per hour. Or again, if you wrote 1.497, that is good as well.
How did you get the 20 numbers?
It's like 8 p.m. from 2 to 8 p.m., but we numbered it 0 through 22. So 20 minus 14. What's our x value? Okay, then go ahead and do that last one. What is the average rate of change from 6 a.m. to 6 p.m.? So that is from 6 to 6 p.m. is what time? What is our number? 18. 6 to 18.
Good morning, Tiger Nation.